Hello ladies and gentlemen, and welcome back to my channel. Let's dive right in. This diagram shows how the ultrasonic sensor works, and it has two main parts. One sends out a sound wave and the other listens for the echo when it bounces back from an object. The Arduino sends a short pulse to the trig pin, which makes the sensor emit that chirp. The echo pin then goes high for the amount of time it takes the wave to travel to the object and back. By measuring that, we can calculate the distance. The formula is distance is equal to speed times echo time divided by 2. The divide by 2 is because the wave goes there and back. So basically the sensor sends a sound, listens for the echo, and the Arduino converts that into distance. That's this whole principle in action. Connecting the ultrasonic sensor is simple. VCC goes into the Arduino's 5-volt pin, ground goes to ground, trig connects to the digital pin 9, and echo connects to digital pin 10. That's it, 4 wires and your sensor is ready for use. Alright, let's get into the code aspect of our project. At the top of the code, we set up our pin numbers. These are the constants, meaning they won't change. Remember how I said trig is the pin that sends the signal, and echo is the one that listens for it, so it's able to determine how far objects are. Next is the setup function, which runs once when the Arduino starts. The first line, serial.begin 9600, opens communication with the serial monitor. That number, 9600, is the baud rate, basically how fast the Arduino and your computer talk to each other. Then we set the trig pin as the output because it needs to send electrical pulses, the echo pin as the input because it's going to receive the response from the sensor. This part of the code only runs once and when you first initialize the code. Now let's look at the loop portion of our code. This runs over and over again. Here's what's happening. We make sure that the trig pin is low, which resets it. Then we wait 2 microseconds. Super fast, but enough for the sensor to settle. After that, we set the trig pin high for 10 microseconds. That tiny pulse is what tells the ultrasonic sensor to send out its sound wave. Finally, we send it back to low. Once the sound wave bounces off the object and comes back, the sensor holds the echo pin high for the amount of time it took. The line measures how long the echo pin says high in microseconds. We stored that value in a variable called duration. Using long here makes sense because the time could be a fairly large number. Now we take that time and figure out how far away the object is. The math works like this. Sound travels at about 343 meters per second, which is about 0.034 centimeters per microsecond. So we multiply the duration by 0.034 to convert it into centimeters, and we divide by 2 because the sound wave went there and back. We only want the one-way distance. Finally, we send the result to the serial monitor. This prints the words distance and the actual number we calculated, and finally the unit centimeters. Each time the loop runs, we'll get a new reading on the serial monitor, about twice per second. Finally, this is what the code will look like once you've put everything together. You've done the hard work, and now it's just time to test our project. As you can see, our project has been an astounding success. As I move my hand closer and I move my hand farther, the values change accordingly. Well done. Pat yourself on the back. This was only part 1 though. Stay tuned for part 2.